This call is now being recorded.
So, welcome for Math Talk. Math Talk is, put simply, a session which talks about how do you get kids to talk about mathematics, how do you get kids to talk maths in the class. And this works whether you teach a group, whether you teach one on one, it kind of works. So, I will be discussing some of the strategies here. So this session I'm going to keep in a kind of a webinar mode. So if you have any questions, you can put in the chat box or you can raise your hand, then I'll pause and answer. Otherwise, when I finish the session, maybe in 30-35 minutes, after that, we can have a question and answer session. So it's completely up to you. So what I'm doing is, I believe that maths classes require a very specific set of pedagogies or teaching strategies, which every teacher should know, like a toolbox, that these are the things I know and I can use in the class. So my sessions on every Saturday, as far as possible, are 14 sessions are there. This is the 9th session, which is Math Talk. After that, I will move to inquiry-based learning, collaboration, assessment, differentiation, Bloom's taxonomy, and then language integration with math. That is going to be the final session of this particular series. So let's start. This is the flow of the current session. What is Math Talk? We've heard it. It's even, I go and work with teachers in municipal schools in Delhi, and even they are talking about Math Talk. Why do we need it? How do we do it? And then examples from the classrooms to show you exactly how it is done. So what is Math Talk? I always like to show teachers a video. And at the end of this session, I will be giving you a PDF of this presentation. So all the source links are here for you to go. And these are all open sources from YouTube. So here I'm going to show you a video from a mathematician who's taken the whole world with like a storm, called Joe Baller. So this is a bit of a peep into how she conducts number talk, which I would say math talk. So just watch what she's doing with some children.
So the first thing I'm going to ask you is just simply to write down the answer without using pen and paper. Try not to use the traditional algorithm, but work out and write down the answer for 18 times 5.
So this is a question she gave to some of the students. Now these students are not technically primary or middle year children. She works in Stanford University. So this is a part of her graduate students with whom she worked like on an experimental basis. So she gave them a question. Normally when we give anyone 18 into 5, immediately the answer is 5 8s are 40, 0, 4 goes up, 5 1s are 5, 90. So, but suppose this algorithm was not there, then how would you solve it? And then the answers come.
You probably got that the answer is 90. But the answer is probably not the most interesting part. The most interesting part of number talks is really thinking about how you arrived at that answer. As of course they used.
That would be nice.
So as she said, Math Talk is about getting children to talk about the thinking that they have used to solve a problem. So here she gave this question and a series of students will give their thinking or their method. So it's not about telling the children your answer is right or the answer is wrong. So let's say 18 into 5, if I ask a child and child says 90, I'm going to say, okay, but how did you arrive at this answer? I'm not going to say, okay, your answer is correct. Another child says 18 into 5 is, let's say, 65. And I'm again not going to say your answer is wrong. I'm going to say, how did you arrive at it? So that's what it is. So let's see how these play acting students respond.
90.
Okay, and how did you get 90?
Well, first I doubled 18, getting 36, then I doubled that, getting 72, and then I added 18 again, so
Okay.
that was my...
90.
And how did you do that?
So I take 18 and I have that. 9 times 5, 45. 9 times 5, 45. Add them together, 90.
18 times 5 is 80.
How did
5 times 10 plus 5 times 8. No, 90.
90.
And can you just describe your method of how you got to that?
I did 9 times 10 instead of 18 times 5, because same thing.
Well, I'll do it out loud then. 18 times 5. Okay, hopefully I don't get this wrong as I'm doing it. I do 20 times 5, so 2 times 5 is 10, add a 0. 2 times 5, that'd be 100. And then minus 2 times 5 again. So that would be minus 10, that'd be 90, I think. But I'm out of.
So this is the experiment she did, with which she realized that children actually think differently and their math needs to come. So one of the easiest ways of doing math talk in class is simply asking the children, how did you arrive at the answer? And the question can be anything. The question can be, what is the value of x if 4x plus 8 is equal to 12? And a child says answer is 2. How did you come to the answer? So how is the critical prefix here? How did you come to the answer? So that is one of the best ways of doing math talk.
But the first thing I'm going to
And so math talk is when students are asked to reason, students are asked to explain. Why did you choose this method? Why does this make sense? And then students didn't think of, is it right or is it wrong? The students were only thinking of, okay, how did I come to the answer? As you saw when the questions were asked to the students in Joe's experiment, one student gave an incorrect answer, but the interviewer didn't say right, wrong at any case. The interviewer said, how did you come to the answer? Another question can be, why did you choose this method over others? Can there be another method to do this? So this is math talk. So let's take a step back and see how does a human mind learn. So human mind learns by experiencing, which is the foundation of experiential learning, that you give an experiment to a child and then through that experiment the child learns. We also learn by making mistakes. We learn by doing, which is a foundation of play-way method. We learn scaffolding, that is we give a little bit of a support to the learners and through that the learners learn. But human mind also learns by discussion. So anytime we have an issue in our lives, we like to discuss. Human mind also learns by thinking aloud. Like I'm one of those. There are times I'm talking to myself and that is I'm just thinking aloud. What do I do in this situation? Should I do this? Should I do this? Should I do this? Human mind also learns by belonging to a learning community. Learning community is where I can ask any question freely. We learn by teaching others and we learn by sharing. So all the blue boxes is where social learning is happening. It's me, I'm talking to myself, I'm talking to others. Math talk belongs to the blue boxes where there is a conversation happening about math. So what is math talk? If we take this question, is it different from simply talking? Yes, because here there is a very clear intention. I want to know how you think about solving this math problem. Is any talk math talk? No. Again, the intention is very, very clear. Is it same as number talk? Maybe. Number talk is only when you're talking numbers. How did you get 12 into 5? What is 12 plus 11? Math talk can be in any concept area. Sum of the 3 angles of the triangle is 180. 2 angles are given. What is the third angle? That is also math talk. Yes, Malay?
Can you give the answer and discuss related to that thing in math
Yes,
talk?
you can also
Can
do
we
that.
give the,
Yes,
if
of
we
course.
have to put one question, then give the answer?
Yes.
Then we
Yes,
have to,
yes,
how
we
to
can do
find
that.
out the answer? Can we discuss?
Yes, we can do that. So let's say
Thank you.
question is, what is 22 plus 23? What is the answer? Somebody says 45, somebody says 46. Okay, how did you come to that? So that is anytime there is a conversation happening, taking math, that is math talk. Is it when a teacher talks in a math talk? No. Math talk is a two-way conversation. Teacher-child or child-child. Is it same as talking in a language class? Not necessarily. Here the intention is very clear that we are doing on math talk. Any other question here? Okay. So this is again one of the ways Malay gave, that you have the answer and then using the answer you have a discussion. Another way is when we ask children, what are you working on? Usually what will children say? I'm working on question 4. I'm working on exercise 1.2. You can always ask them, what is the math that you're working on? And the child may say, I'm working on chapter linear equation exercise. So what is the math that you're doing? And then after 2-3 times, the child answered, oh, I'm solving questions on how to solve a linear equation with variable on both the sides. So this is also another way of getting children to think and converse mathematically. So Purvi, when you're teaching in a class, it would be very interesting for you to ask a child, what is it that you're working on today? And if a child just gives the name of the chapter, you can ask them, what is the math that we are doing in this chapter? And that gets them to think about maths. So that's how you take this conversation forward, that you keep poking, you keep probing the child, that what is the math that is being worked on. So how do we ensure that math talk happens? This has 5 moves, 5 suggestions I will give you. One is, if a student has said something, simply repeat. So a student asks, what is x plus 3? What is x if x plus 3 is 7? And the student says answer is 7. And the teacher says, okay, are you saying the answer is 7? And that will instigate the child to speak. Yes, I think the answer is 7. The other is asking students to restate someone else's reasoning. So taking the same question, x plus 3 equal to 7. One student says answer is 4 because I put 3 on the other side. So another student can be asked, what is the reasoning that child number 1 has given? Can you repeat it? Asking students to apply their own reasoning. So x plus 3 equal to 7. X is 4 because I transpose 3 to the other side. So I can ask another student, is this correct or incorrect? Prompting students for further participation. One person is given the answer, asking someone else, what do you think is the answer? Why do you think this is correct? Why do you think this is incorrect? Just picking children and asking them to answer using wait time. So taking, let's say, telling the children, I'm going to give you 30 seconds or 45 seconds before I move on or before I take the conversation forward. So these are just 5 important math moves, 3RPW, which can be used in the class. I think at any grade, any concept, these can be used. So I want to show you here another video, which is from,
We're going to try a different.
Again, Stanford, in Stanford University. So this is partner of Joe Boller, working with students in Stanford. I'm going to, this is a 14-minute long video, but I'm going to show it for 2 to 3 minutes only. Just watch. And after that, I can pause and ask you, what is it that you notice in this video? Just watch how she's instigating the children to talk. So that's the role of the teacher. You have to trigger the kids to keep talking. And if the focus is only correct answer, conversation never happens. But if the focus is getting the children to talk, then certain strategies are in use.
Different number talk this time, and this time it's with numbers, and it's going to be multiplication. Okay, so get ready to think, and the problem is
so she has given the children a problem 25 into 29, and she's going to ask them to solve and explain their reasoning. So the thing is, explain your reasoning. And the way she's managing the
Thank you so
classes, if you see the hand position of the children, those who want to answer, they have their fist up.
It's already up. You might try to see if you could see it a different way.
See how she's waiting. She's letting them wait. She's not in a hurry to say correct answer or incorrect answer. So one child has
Does
said
anybody have another idea about what the answer might be? Okay, Shay?
725.
Hold on. Does anyone have a different idea about what the answer might be? Okay, so Joe, what's the matter?
I realized what I did. I think Shay and I probably both got to 750, but she accurately subtracted 25, and I subtracted 30.
So Malay, this answers your question. She's given a question. She's just collecting all the answers first. Is this what you were asking?
Yeah. Didi. Yes, Didi.
Okay. So this is, yeah. So this video is then for you. Yeah.
Because I was confused by the rounding I was doing from 29 to 30.
That's good. That's good. So I'll have you actually. So you're saying that you want to disagree with this answer?
I want to disagree with my answer. Yes.
Okay, and so you're agreeing that the answer is 725.
Yes.
Okay, so let's go through your method then, Joe, and you can show us what you did wrong.
What I did was I rounded 29 to 30.
Okay, so we're doing 25 times 29, but you decided to do 25 times 30 to.
Mm-hmm.
Because
30 is a friendly number and easier to multiply with.
All right.
And then what I did was I broke 25 up into 10 plus 10 plus 5. So what that does is you can multiply 30 by each of those numbers. So that turns into 300 plus 300 plus 150.
So you multiplied 30 times each.
I'll just run a little ahead so you can see how she's dialoguing with other kids also. Please note, this is an experimental class. So she's demonstrating it, and it's like a lab experiment.
Each one of those numbers,
Yes.
10 plus.
Equation, I would.
And then
then necessary, and so I'll subtract that 25 away from 750. So 750 minus 25.
So this is how the
Joe,
session
it's
goes,
similar to 75.
where she goes child by child, she goes experiment, she goes. So the way the teachers, I don't think as teachers, you may have time every day to do so much, but adapting a little bit would simply be, how did you get the answer? Maybe asking 2-3 children, writing the answers on the board and saying, how did you get the answer? Why do you think the answer is this? So when a child says, I think answer is 720 because, it's what is being said after because is the math talk happening. So that is the thing to be taken into account. So let me give you some examples. How do we ensure math talk? By asking questions. For example, in a junior class, do these both show 5? How do you know? And there's the trigger. And later, I'll give you a list of questions that every teacher should have in his or her pocket to ensure math talk. So the teacher's job is only to ask questions. How do you know both of them show 5? And then the child will say something, asking someone else, do you agree with this, what child number 1 has said? Asking child number 2, asking child number 3, do you have something else to say here? So this is a part of inquiry-based learning. And the only thing the teacher is doing is asking questions. At the warm-up time, having a very engaging hook to class, start the class, engaging the kids right in the beginning at a warm-up. For example, have you observed something very strange about this? And then all the children are thinking. And there is an open-ended question over here. So this is another way, another time to ensure math talk is just at the start of the class, when the class has started. And as you can say, answers may vary. That means that this is an open-ended question. Probing questions. For example, if there's a question, what grid size other than 100 tiles can be there to show 60% blue tiles? And then the child will try and solve this question, and then asking more and more questions. How do you know this is correct? Do you think the denominator can be something else? What is the denominator when we convert 60% to fraction? So that is also another space when questioning happens, when the children are working on problem solving, and that is the time questioning can be done. Error analysis is one of my favorite ways when I used to teach maths, and today when I do curriculum designing, is error analysis questions, where you purposely give a question and you say, is this correct? And justify your answer. Is it correct? Would you say yes because? Would you say no because? Justify your answer. So the moment a child has to justify his or her answer, the child is thinking. And when the child is thinking, the child is developing the logical intelligence. So that is another very great point of introducing Math Talk, is deliberately giving an incorrect question or an incorrect solution to a child, and then asking, justify. Do you think this is correct or this is incorrect? This can be done when the teacher is teaching. It can also be done when children are sitting in groups or children are sitting in pairs, and then the pairs can talk to each other. I think this is correct. I think this is not correct. Giving the children, okay, I'm giving you 3 minutes to discuss whether this is correct or incorrect. And these are some of the sentences that children can use. This is a poster from a classroom. It can be put up on the class. I noticed you said 17 and 7 is 23. I noticed that your solution to your quadratic equation is both the roots are same. How did you get that? Or when children are talking to each other, I agree with you, but I don't agree with you. This really makes sense to me. Even if you take one question out of this, how do you know you are right? That itself will instigate a lot of conversation in the class, because a child may say 8x and 8x is 9x. How do you know that? That's it. And the child will have to then explain, I know 8x and 8x is 9x because, and that's where conversation on math starts. So this is another of a quick tip. Any questions here? Just check the chat box. Okay. Yeah.
Monica ma'am, actually I do this kind of talking where you said, no, justify, or is this a correct way of doing?
Yeah.
So I do instigate my students to tell me that, how can the question be attempted, or what possibly could be another way of doing it.
Yeah.
But sometimes I do make a change in the question. For example, if the question is related to finding sum of even numbers between 0 to 50.
Yeah.
So I usually change the question that if I make it 1 to 50, what difference will come?
Yeah.
Or if I make it odd. So that also is considered as a math talk.
Absolutely. And that's a fantastic way. That's like, addition to my portfolio. Anytime you're getting children to show their reasoning out there, out aloud, that's a part of Math Talk. Thanks for sharing that.
Thank you.
So let's look at a classroom now, and a short video here on conversation will be happening, where you will see that it's a very dynamic environment.
Is there a point where you got stuck? And if so, describe specifically what confused you.
Yeah, I got stuck in the beginning because there wasn't really.
So this is what I meant to say. When students explain their math reasoning, understanding deepens. So anytime you're getting the students to explain their reasoning, that's Math Talk happening.
A story to it.
The purpose of the math interview is to really get them using that questioning language. It really strengthens the discourse between the kids.
How did you solve the rest of the problem?
Good morning, everybody. So we're conducting our math interviews today. Before I started, I would get a.
So math interviews is a way of getting Math Talk going on in the class, which was tried out by this particular teacher. Just wanted to highlight this.
A lot of, I don't know. I don't even know where to start. And now, before they call me over, they've either asked a peer, looked around to check the anchor charts, or they've written down something that they know about the problem. Each of you will be given one task. Either you'll be task A or you'll be task B. First 5 to 7 minutes of class, you work on your problem, I work on mine. We cannot help each other at all. But you don't have to have the right answer to conduct the math interview. So task A, write your partner's name on your paper, on the interview paper. Everyone has the document with the questions all laid out. With task A, you can begin interviewing task B. Now it starts out very scripted. The very first question is, when you read this problem, how did it make you feel? That question is rarely asked in math.
Did you understand what the problem was asking yourself?
And then you get into the nitty gritty.
How did you solve the rest of the problem? What steps did you take and why?
I had to do line equals sign method,
And so now the kids can enumerate the things that they did.
and then I had to divide.
Once you get all of those out, you get more into the like, okay, let's get into reflective questions, okay? Have you ever seen a problem like this before?
Is there a point where you guys stuck?
There was a point where I didn't know if the 4 goes over the 36 or the 36 goes over the 4.
Did you give up or did you figure out a way to move forward?
I figured out a way to move forward.
You can go ahead and switch if you have already finished the first interview. After you interview me, if I didn't finish my problem, you can now help me, but only after the interview, because you want the thoughts to come out as pure as possible.
What did that step help you know or figure out?
One thing I'm really walking around listening for is, one, are they sharing their ideas?
When they gave me the 3.5, I knew from there to what to multiply.
How did you know what to do? And then obviously I'm looking for that vocabulary of math. And then we could even say, I divided the dependent by the independent. Are you able to articulate yourself using that math language? And also, I'm just looking to see how well they are engaging each other in the interview. It's scripted and it sounds robotic at first, but after you do it so much, kids sort of internalize it. This is how I should ask a question. I shouldn't approach you and say, hey, what's your answer? That has no substance for me if I'm trying to truly learn from you. If I ask you, hey, can you explain to me how you did this? What was step number 1? Why did you do that step? So it's that constant questioning.
Did you give up? I didn't give up because I knew the steps to take, and I took my time to do it and not give up.
So that's the beauty of the math interview.
So this was a beautiful video, so I thought I'll share it here, which kind of completely describes how do we start math talk in the class. So in the beginning, there can be scripted questions. In the beginning, as a teacher also, you can go with some scripted questions. The best beginning would be one of the beginnings, I think Malay has given an example, start from the answer. Ankita has given the answer another way, that if you have a question, change the question and ask the children, if I change 50 to 500, what will happen here? And another way the teacher in the video has given, which is that start with some scripted questions, which can simply be, how do you know this is correct? How did you know where to start this question? So that is the way. So one of the best ways to do math talk, to remember, is to have, this is something which should be in the pocket of every teacher. There is a formula called as 5W and 1H, what, who, where, when, why, how. So you can ask, why did you use this method? What will happen if in the question I change 5 to 7? Where did we learn this before? How do you know this is a correct answer? Who do you think requires this particular topic? Let's say the children are always asking, no, why are we learning math? So even that can come in a math talk classroom. For example, I used to always ask the children in a class whenever I started any chapter, who do you think needs this? Who do you think needs fractions? Which profession do you think requires scientific notation? And the children used to think or research and come back and say, yes, this particular professional would be very handicapped without this. When did we learn this before? But out of all these, I think why and how are two fantastic things to keep in your pocket. How do you know your answer is correct? Why did you choose this method? Why didn't you work in this way? How will we solve it if the answer is 12.5 instead of 13? How do I know where I have gone incorrect? So 5W1H is a great way to do math talk. And after that, I think why, how, or as Ankita described, even what is a great way to get children to talk about their method. So summing up, math talk is a discussion or a conversation in a maths class. It can be happening between 2 students, 3 students, a group of students, or it can be happening between a teacher and a student. Secondly, it is a way for students to explain their reasoning about concepts, about problem-solving strategies. And what happens is, mostly, if an answer is incorrect and a child is sharing his or her strategy, most of the time the child himself notices, yeah, I made an error here. Or the child or the teacher understands, okay, this is the error in the logic of the child. So this is the this is the purpose of it, that the thinking becomes very visible of the children in the class. Characteristics of math talk: generally ask open-ended questions. Always explain to children what they are expected to do, like the teacher in the video explained, that he tells the children first one child will ask all the questions, then another child. Have some rules in the class. Sometimes you can have, if you're asking the children answers, just write all the answers on the board. Don't say right, wrong. I think that is a teacher's self-development time needed. We are always in a hurry to say you're right, you're wrong. So get out of the right, wrong mindset. Let the students explain their strategy to the class. Another way is to keep these 12 possible questions given by a teacher. The source is here for you to explore later. Suppose somebody gives an incorrect answer. What did you notice about your steps? What do you think? If somebody says, this, I think this answer is correct. I ask somebody else, what do you think? Somebody comes running to me and says, I got the answer to the question you asked. My question will be, how did you figure that out? Okay, I think 2 + 7 is 9. Can you prove that? And then what if, what if in this question 2x + 2y = 11, what if I changed 11 to 13? What happens to the equation? Does anyone have a different way of thinking about this? Can anyone add on to this person's idea? Can you convince me that you're right? That would be a fantastic way to ask. Give semi-solved question on the board. Can you predict what will happen next? How do you know what you know? Do you agree? And do you see any patterns here? Have we done this before? I think even if as teachers you take 1 question a day and experiment within the class, within 12 days, you would have a classroom where children have started talking to each other as much as possible within your time frame. It could be maybe for 3 to 4 minutes in every maths class. If you get, let's say, one group of kids talk one day, another group, I think within 12 days, you will have a very different environment in your classroom. So this is a good source, I feel, that can be explored to initiate math talk in the class. So that's about it. Now it's like an open house, and the small group which is present here, I think most of you are already using this strategy. Would you like to share if something new was learned today? This is the time when you can share or you can ask questions, but would you like to share anything new did you learn today? Malay, Purbi, Ankita?
Yes, Didi. Basically, it is student engaging class. It means no need to talk maximum by the student by the teacher. Most of the just we have to guide the student, and the student will they do the class on their own.
Yeah,
we are just helping them,
absolutely.
not as a teacher, just as a guide.
Yeah. That's a great way to. Did you pick any new strategy today, Malay, to do this?
Yeah,
Which of the
Didi.
strategies? Because I shared a lot of strategies. Which one did you like a lot?
Basically, we have to give the question and try to find out the logic behind it. What is the logic that we have to find out the answer? In which way we can do the better? It means the same question, the answer is same, but the way of thinking is different.
Absolutely. And different children can bring out the different thinking. Yeah, that's absolutely right.
Yeah.
Thank
And
you.
basically,
Would anyone else like to?
most of the students, they are just participating in class.
Yeah. Thanks, Malay. Would anyone else like to share?
Yeah, ma'am.
Monica, ma'am,
I think actually I have.
Yes, please. We'll take Shravanti and then Ankita.
Yeah, ma'am. Ma'am, actually, I have learned about how in different ways I can ask a question in the class so that I can implement the math thinking in the children and their perspective on the subject and their clarity on the subject can be more understood by me by asking them in different ways the questions actually.
Yes, that's right. Thank you. Thank you for sharing that.
Thank you.
Yes, Ankita?
Yeah, actually, Monica, what I do is once the exams, especially when exams are over, because this is a very common scenario that my child is good at home in doing.
Yeah.
And exam just don't perform the way it should be, right? This is a very common scenario. So usually I just discuss one-to-one quickly in terms of what the child has done in the paper and what should it be. But now when I looked at that math interview thing, I just got an idea that rather than me only telling them that what it should be, I can actually talk to them that what were they thinking while writing those answers, or what exactly was the state of mind when they were writing all that, and those kind of mistakes has happened may give me a better picture of what they go through during exams, and I can help them in performing better in exams.
That's a very beautiful insight. Even I felt that math interviews, especially the first bit when the teacher asked, how did it make you feel? That was a very beautiful thing. Yeah. Thank you so much. Thanks for sharing that. Purbi, would you like to share something? So Purbi is in a very different world. She takes one-to-one online classes. Yeah. Purbi, did you pick something for your part of the world here?
Yes, ma'am. Actually, I like that strategy that using that 5W1H. That one is very good. And one more thing is that basically don't tell the answer it is correct or not.
Yeah.
Means what actually I do, I when given the question and ask the same thing like how you arrived there, how you got the answer, why you choose this method. These things I used to do, but I just tell the answer first that yes, it is correct. Then I asked.
Yeah.
So I should do this, that I shouldn't tell them that what will be the answer. Is it correct or not?
That's great. That's great. Thank you so much. Thanks, four of you. I always find small groups are great to join. And next Saturday, I'll be taking a session on inquiry-based learning, which is a bit of an extension, but I'll use something called as a 5E model, which is very handy in building lesson plans and also designing the classes. So I hope all four of you join that also. I'll send the information on it.
And what will be the time, Didi?
Next
5 o'clock?
Saturday, it's at 5 p.m. And usually I keep it Saturday 6 p.m. But next Saturday I have some work, so it's going to be 5 p.m. And